Okay, hi everyone, welcome back to this live stream for Windows Server 2003 administration. So the security tab. The security tab helps you regulate which routes your RIP interface will accept from and broadcast to its peers. There are good reasons to be careful about which routes you accept into your routing table because a malicious attacker can simply flood your router with bogus routes and watch laughing as your router sends traffic off on a wild goose chase. Likewise, you may want to advertise every route in your routing table, particularly if the same routers handle both internet and intranet traffic. You can use the controls on this tab to discard routes that fall within a particular range of addresses, or you can accept only those routes that fall within a particular range. So you can see here figure 912, the security tab of the RIP interface properties dialog box. The default settings is to accept all routes, but you can change it using these controls. The action drop-down list lets you choose whether you want to impose settings on incoming routes that your router hears from its peers or on outgoing routes that it announces. Depending on which of these options you choose, the wording of the three radio buttons below the drop-down list will change. The From and To fields, the Add, Edit and Remove buttons, and the address range lists are all used to specify which set of addresses you want to use with the restriction radio buttons. The restriction radio buttons in the center of the dialog box control the action applied to incoming and outgoing routes. The default setting announce all routes for outgoing routes or process all routes for incoming routes does just that. All routes are accepted or announced no matter the source. Selecting all routes in the ranges listed outgoing or accept all routes in the range listed incoming causes RRAS to silently ignore any routes that fall outside of the specified ranges. You normally use this option when you want to limit the scope of the routes over which your router can exchange traffic. The do not announce all routes in the range listed outgoing and ignore all routes in the range listed incoming settings tells RRAS to silently ignore any routes that fall within the specified ranges. This is useful for filtering out routes that you don't want to make available or those you don't want to use to reach remote systems. The Neighbors tab. The Neighbors tab gives you a finer degree of control over how this particular interface interacts with its peer RIP routers. By specifying a list of trusted neighbor routers, an OSPF concept that Microsoft's mixed into its RIP implementation, you can choose to use neighboring routes in addition to or instead of broadcast and multicast RIP announcements. So you can see here 913, figure 913, the Neighbors tab of the RIP interface properties dialog box. You will use the following radio buttons on the Neighbors tab. The Use Broadcast or Multicast Only radio button tells RRAS to ignore any RIP neighbors. This is the default setting. It means that any router that can successfully broadcast or multicast routes to you can load its routes into your routing table. The Use Add Neighbors in addition to broadcast or multicast radio button tells RRAS to accept routes from RIP peers as well as from neighbors you've specified. The Use Neighbors instead of broadcast or multicast radio button indicates that you don't trust RIP announcements that your router picks up from the network. Instead, you're telling RRAS to trust only those neighbors that are defined in the neighbor list. You manage the list of trusted neighbor routers using the IP address field. The Add, edit, and remove buttons and the list itself. These controls are enabled when you specify that you want to use neighbor supplied routing information. Once the controls are activated, you can add router IP routes to the neighbor list. The Advanced tab. The Advanced tab contains 12 controls that govern some fairly esoteric RIP behavior. The three first controls are only active when you turn on periodic update mode on the General tab. The periodic announcement interval seconds field controls the interval at which periodic router announcements are made. The time before routes expires seconds field controls how long the route may stay in the routing table before it's considered to be expired. The arrival of a new RIP announcement for the route resets the timer. It will be marked as invalid only if it reaches the expiration timer without being renewed through a new announcement. The time before route is removed seconds field controls the interval that may pass between the time a route expires and the time it's removed. The next group of checkboxes controls update processing and loop detection. The enable split horizon processing checkbox turns on split horizon processing, in which a route learned by an RIP router on a network is not rebroadcast to that network. Split horizon processing helps prevent routing loops, so it's on by default. The enable poison reverse processing, which is active only when the enable split horizon processing checkbox is on, modifies the way split horizon processing works. When poison reverse is turned on, routes learned from a network are rebroadcast to the network with a metric of 16, a special value that tells other routers that the route is unreachable. It also prevents routing loops while still keeping the routing tables up to date. The enable trigger updates checkbox indicates whether you want routing table changes to be immediately sent out when they're noticed, the default or not. Triggered updates help keep the routing table up to date with minimum latency. The send clean up updates when stopping checkbox controls whether or not RRAS will send out announcements that mark the routes it was handling as unavailable. This immediately lets its RIP peers know that the routes it was servicing are no longer usable. The last set of controls governs what happens with host and default routes. By default, RRAS ignores any host routes it sees in RIP announcements. Turn on the processed host routes in received announcements checkbox if you want it to honor those routes instead of ignoring them. The include host routes in sent announcements checkbox directs RRAS to send host route information as part of its RIP announcements. Normally it won't do this. The process default routes in received announcements and include default routes in sent announcements checkboxes have the same function as their host route checkboxes described earlier. The disabled subnet summarization checkbox is active only if you have RIP version 2 specified as the outbound packet type for the router. When subnet summarization is turned off, RIP won't advertise subnets to routers that are on other subnets. Setting OSPF interfaces. OSPF has its own set of properties that you can set on OSPF-enabled interfaces. Setting these properties is both simpler and more complex than RIP. Simpler because there aren't as many of them because OSPF is largely self-tuning. But the properties you can set tend to somewhat more obtruse. You can use OSPF's interface properties dialog box by selecting the OSPF node, clicking the interface in the right window pane, and selecting properties from the actions menu. Let's take a look at the options available in an OSPF's interface properties dialog box, the General tab. The General tab of the OSPF properties dialog box controls, among other things, whether or not OSPF is enabled on a particular interface address. Here's what you can do with the controls on the General tab. The Enable OSPF for this address checkbox, combined with the address drop-down menu, specify whether OSPF is active or not on the selected address. Because a single interface can have multiple IP addresses, you can use this checkbox and drop down to specify which IP addresses are OSPF capable. The settings you make in the OSPF properties dialog box apply to the IP address you select here. The area drop down allows you to select which OSPF area this interface is part of. There's a simple rule: one IP address can be in one area. If you have multiple IP addresses defined, each one must be in a separate area. The router priority field controls the priority of this interface relative to other OSPF routers in the same area. OSPF supports the concept of a designated router in an area. The router serves as the default router for the area it's in. The router with the highest priority will become the designated router unless there's already an existing designated router. The cost field controls the metric attached to this router's routes in the link state database. The password fields work just like it does for RIP. All routers within an area can share a common plain text password for authentication. This does nothing for access control, especially since the default password is easy to guess. The network type controls influence how this router interacts with its peers, but to understand what it controls, you have to know the following. A broadcast router is one that can talk to any number of other routers, like a typical LAN router, which can see any number of other routers on the LAN. A point-to-point router is one that has only one peer. For example, a typical digital subscriber line DSL installation will have one router on your end and one on the ISP's end. That's a point-to-point configuration. A non-broadcast multiple access NBMA router is a single router that can talk to multiple peers without using a broadcast, as in an asynchronous transfer mode ATM or X25 network. You use these radio buttons to specify what kind of network your router is participating in. If you set your router to NBMA mode, you can use the NBMA Neighbors tab to specify which routers your NBMA router should talk to. The NBMA Routers tab. Think back to the description of RIP Neighbors. You learned that Microsoft had recycled an OSPF concept for use in RIP. The NBMA Neighbors tab then should look like the Neighbors tab of the RIP Interface Properties dialog box. As it happens, the two are very similar. The IP address drop-down list lets you pick the IP address whose neighbors you're configuring. Once you've picked an IP address, you can use the remaining controls in the tab to specify the IP address and priorities of the NBMA neighbors you want this router interface to talk to. The Advanced tab. The Advanced tab contains the advanced features of the OSPF Properties dialog box. First, you can choose which IP address you're configuring. Next, you'll need to use the 6 fields that give you access to some inner OSPF workings. The 6 fields of the Advanced tab include the following. The transit delay field specifies how long you think it'll take for a link state update to propagate outwards from this router. This value is used by the OSPF engine to decide how stale route information is when it arrives. So you can see here figure 917, the advanced tab of the OSPF properties dialog box. The retransmit interval seconds field is for your best estimate for the round trip delay required for two routers to communicate. If it takes longer than this interval for a packet to arrive, it will be transmitted. The hello interval field controls how often OSPF routers send out "here I am" packets to discover other routers. The value must be the same for all routers on the same network. Lowering the interval will speed up the discovery of topology changes at the expense of generating more OSPF traffic. The dead interval field controls the interval after which a router is marked as dead by its peers. Microsoft recommends using an integral multiple of the hello interval from the dead interval. For example, if your hello interval is set to the default of 10 seconds, the default dead interval of 40 seconds will work fine. The pole interval field controls how long an NBMA router will wait before attempting to contact an apparently dead router to see whether it's really dead or not. This interval should be set to at least twice the dead interval. The maximum transmission unit MTU size byte field regulates how big an OSPF packet can be. Your best bet is to leave this value alone. Setting IP routing properties. The routing node in the RRAS console has several subnodes, including the general node. When you click the general node and select properties from the action menu, you'll find that there are settings you can change that apply to all installed IP routing protocols on the server. These settings give you some additional control over how routing works. In the following sections, we'll look at the options in the General Properties dialog box. These options are available for configuring settings to IP routing in general. So I'm going to leave it here this evening for this video. So thanks for spending with me and have a good evening.